Good morning, students. How are you all? I hope all you are safe by God's grace. See, we are learning maths, almost the basic things which is related to grade 11. Try to copy down the notes in the notebook. Okay? In the interactive session, I will check it whether you have written or not. Say, in today's class, we are going to learn about combinatorics. That's from chapter 4. Chapter 4 is combinatorics and mathematical induction. We are going to learn only about the combinatorics. That is the fundamental. The first thing is the fundamental principles of counting. There are three rules. The first one is sum rule, then product rule, the inclusion-exclusion principle. First itself I said fundamental rules of counting. Means number of ways to select. Okay. So sum rule when we will use in the sense, if in the question it is asked selection either this or that or any one, select any one or select this or that, means we have to use the sum rule. And the next one is this and that. This and that means we will be using the product rule. And the third one, inclusion exclusion principle, that is happening simultaneously. When it is happening simultaneously, when the task is done by simultaneously, we have to use the inclusion exclusion principle. Let us learn the definition. Okay. Sum rule. Let us consider two tasks which need to be completed if the first task can be completed in m different ways and the second in n different ways. And if this cannot be performed simultaneously, then there are m plus n ways of doing either task. This is the sum rule of counting. So first task can be completed in m different ways and second task in n different ways. Then the number of ways is m plus n. For example, I have 3 ink pen and 3 ballpoint pen. I need to write. So how many ways is there to select a pen? So 3 ink pen, either any one only I will be using. So 1 ink pen I can use or any one ballpoint pen. So total 3 plus 3 is equal to 6. That's what the sum rule. Okay. Then product rule. If the first procedure can be completed in m different ways and the second procedure can be done in n different ways, after the first procedure is done, then the total number of ways of completing the task is m into n. What is the meaning that after first procedure is done? So it's not completed simultaneously. After completing one, the next one has happened. Say, an example, I have 5 apple and 5 orange. I need an apple and an orange. How to do it? I need an apple. I need an apple as well as an orange. So here 5, there 5. So here first one I can select, then from the orange anyone I can select. So total 5 into 5, 25, since I need both. Okay. So 5 into 5 is equal to 25. So 25 ways is there to select. Okay, that's the product rule. And the next one, as I said, that inclusion exclusion principle. See, suppose two tasks A and B can be performed simultaneously. At n of A and n of B represent a number of ways of performing the task A and B, independent of each other. That what is the meaning of independent of each other? Not related to each other. And let A intersection B be the number of ways of performing the two tasks simultaneously. at a time, both has to be done. That time we cannot use sum rule to count the number or the product rule. So to obtain the correct number of ways, we add the number of ways by performing each of the two tasks and then subtract the number of ways by doing both tasks simultaneously. See, this method is referred to the principle of inclusion-exclusion. See, this formula we know very well, isn't it? N of A union B equal to N of A plus N of B minus N of A intersection B. So let me give the same example which is given in your book. To find the number of positive integers divisible by 2 or 7 but not both. So either it should be divisible by 2 or it should be divisible by 7 but not both. Not both, isn't it? How to find it out? See, let N of A denote the number of integers divisible by 2. N of B denote the number of integers divisible by 7. And N of A intersection B, that is the number of integers divisible by 2, that is 2 and 7. Then the positive integers, see, N of A union B, N of A divisible by 2 is 500 numbers will be divisible by 2 and 142 numbers will be divisible by 7 and divisible by 2 and 7, that is 71. So 500 plus 142 minus 71. Just to make you to understand this inclusion exclusion principle, I told this example. It's very simple. By doing the sums, it will be very much understand. See the fundamental principle of counting. Once again we recall it: sum rule, product rule, the inclusion exclusion principle. Sum rule, or in the question if it is asked this or that, we have to use the sum rule, m plus n. Product rule means and, both we need. So and m into n. Inclusion, both will be doing simultaneously. So n of A union B is equal to n of A plus n of B minus n of A intersection B. Now moving to the problem. See example 1. Suppose one girl or one boy has to be selected for a competition from a class comprising 17 boys and 29 girls. In how many different ways can this selection be made? I need one girl or one boy. See, number of girls. Number of girls is 29. The same way, number of boys equal to 17. Now, number of ways to be selected. Number of ways to be selected is equal to, since this is asked, this or, can use 29 plus 17. So, how much we may get it? 46. Example 2. A school library has 75 books on mathematics, 35 books on physics. A student can choose only one book. Only one book. In how many ways a student can choose a book on mathematics or physics? A school library has 75 books on mathematics, 35 books on physics, and a student can choose only one book. That is important. In how many ways a student can choose a book on mathematics or physics? So this or that. So it's very well understood. We have to use the sum rule. So if we are writing the step, number of mathematics books, that's equal to 75. Then number of physics books equal to 35. Then number of ways to choose a book Simple, 75 plus 35. So total 110. It's simple, right? One more example. Third problem. A person went to a restaurant for dinner. In the menu card, the person saw 10 Indian and 7 Chinese food items. 10 Indian and 7 Chinese food items. In how many ways the person can select either an Indian or a Chinese food? So only one food he is going to select, either it's Indian food or Chinese food. So the same way solution, number of Indian food is equal to 10. Then number of Chinese food is equal to 7. Now number of ways to select an food item. It's just enough to add since the word or is given. So the number of ways is 17. See, still now we did the example with sum rule. Now shall we move to the product rule? Say the example. Consider the three cities Chennai, Trichy and Tirunelveli. In order to reach Tirunelveli from Chennai, one has to pass through Trichy. There are 2 roads connecting Chennai with Trichy, and there are 3 roads connecting Trichy with Tirunelveli. What are the total number of ways travelling from Chennai to Tirunelveli? See, in the question it was given, from Chennai to Trichy there are 2 roads, and from Trichy to Tirunelveli there are 3 roads, and a person needs to travel from Chennai to Tirunelveli. Anyway, he has to cross Trichy to go to Tirunelveli. So both we need, this and that. So the number of ways, can you tell me? As we know, the number of ways is equal to m into n. Here 2 into 3, that is equal to 6. Is it clear? Shall we move to the next example? Example 5. A person wants to buy a car. There are 2 brands of car available in the market, and each brand has 3 variant models. 3 variant models, and each model comes in 5 different colors. In how many ways she can choose a car to buy? A person needs a car. There are 2 brands of cars available in the market, and each brand has 3 variant models. Okay, and each model comes in 5 different colors. In how many ways she can choose a car to buy? Anyway, she needs a car. 2 brand, any one car she is going to select. In that 3 variant model is there, that model also she need, and 5 different color, any one color also she need, isn't it? So 2 cars from that 3 variant models, from the 3 variant models 5 different color is there. So the number of ways is equal to 2 model cars from that 3 variant models, and in that 5 different colors. So total 2 into 3, 6, 6 into 5, 30 ways is there to select a car. The next one. A woman wants to select one silk saree and one sungudi saree from a textile shop located at Kanchipuram. In that shop, there are 20 different varieties of silk sarees and 8 different varieties of sungudi sarees. In how many ways she can select her saree? See, she needs silk saree as well as sungudi saree. So, what about the number of ways? The number of ways, silk saree is 20 models, 20 saree is there, and sungudi saree 8 is there. So 20 into 8 is equal to 160 ways. Is it clear? Next example. In a village, out of the total number of people, 80% of the people own coconut groves and 65% of the people own paddy field. What is the minimum percentage of people who own both? So single they did not ask, who own both they have asked. This is using set theory we can do it. See, let of A denote the percentage of the people who own coconut groves, and N of B denote the percentage of people who own the paddy field. So what's that? N of A coconut groves, that is 80%, and N of B paddy field 65%. They have asked both, so N of A intersection B we need to find it out. And percentage means, what is the meaning? Out of 100, 80% means out of 100, 80 people has got a coconut groves. So we can take the total number of people, that's N of A union B is equal to 100, since it's given in percentage. Okay, we have the formula N of A union B is equal to N of A plus N of B minus N of A intersection B. So that is, from this, N of A union B 100, N of A 80 plus 65 minus N of A intersection B. This we need, isn't it? Shall we take to the left hand side? This negative, when it comes here, it will become positive. So 80 plus 65, 145 minus 100. So our answer is 45. So in words, if we write 45% of the people own both paddy field and coconut groves. That is, answer is 45% of the people own both coconut groves and paddy field. Okay, so till this we have seen that examples from sum rule, product rule, and this is only one example we have in inclusion and exclusion. In exercise also no problem is given related to inclusion exclusion principle. Okay, now we can move to the next easiest one. Using the words will be given, and how many different words we can form from a word. One word will be given, and how many different words can be formed from the given word. Shall we move to that? See, string. First we should know what is meant by string. A string is formed by writing given letters one by one in a sequence. String is the formed by writing given letters one by one in a sequence. See, example 8, find the number of strings of length 4. So, the number of letters is 4. String is nothing but the word formed by arranging the letters one by one in a sequence. See, which can be formed by using the letters of the word bird, B-I-R-D. It also consists of how many letters is there? 4. Without repetition of the letters. So, what is the meaning? Once used cannot be used again. Once used letters cannot be used again. So, 4-letter word. So, I am giving 4 dash. Isn't it? We have 4 words. See, for the first place, we have 4 words, 4 letters. See here, in the first place, I can use any one letter. So, 4. In the second place, here one letter will be fixed, isn't it? One alphabet will be fixed. So, the second place, second chance, we will be getting only 3. Because 1 is fixed. So after coming here to the third place, already 2 letters are fixed. So the remaining is 2. Now coming here, 3 letters are fixed. So the remaining remaining letter is 1. So here that is 4 minus 1, here 4 minus 2 and here 4 minus 3 since we have filled. Now you can write number of strings is equal to 4 into 3 into 2 into 1. So 4 into 3 12, 12 into 2 24, 24 into 1 is 24. Is it clear? This is what? Number of strings. Shall we do one more problem related to that? It's little interesting. Say, how many strings of length 5 can be formed out of the letters of the word prime, P-R-I-M-E, 5 letters given, taking all the letters at a time without repetition. Here also without repetition. So, shall we do it? So, how many? 5. So, I am giving 5. In that first place, 5 possibilities there. Here 5 minus 1, 4. 5 minus 2, 3. Here 2, 1. So, number of strings. 5 into 4 into 3 into 2 into 1. So, 20 into 3, 60. 60 into 2 is 120. See, the next classes also we are going to use this methods in different ways. Here it is given without repetition. With repetition means what is the method? If first word letter is fixed, how to arrange the remaining letters, or if last letter is fixed, how to arrange the other letters. Okay? So listen, try to copy down all this in the notes. Today no work done is given for you. Thank you. See you in the next class. Bye bye.